Welcome to Vision Plus and welcome back to this for Mathematics. We are looking at finding the equation of the tangent to a circle at a given point. So we're starting with example 1. Example 1 part A says that find the equation of the tangent to this circle at this point. So part A, the circle is x squared plus y squared plus 2x minus 2y minus 8 equals to 0. At which point? At point 2 and 2. Here, it is not very necessary for us to sketch the circle. But to make our understanding better, let me sketch the circle. This is the circle. It has the center there. Now we have the tangent in this manner. So the tangent is coming from some point. Let me call it B. But remember, this point that they are saying here is the point where the tangent meets the circle. So it is actually here. Let me call it point A. This is point A to 2. Because this is the tangent to the circle. At what point on the circle is the tangent touching the circle? It is touching the circle at point 2. Okay? This point 2 is not where the tangent is drawn. You must be careful so that you understand that. So the tangent is drawn from some point B that they have not told us to the circle, and then it meets the circle at point 2. Now in this case here, when we are looking for the equation of the tangent, knowing the center of the circle and knowing the radius are not so much important. So we are not going to find the radius and the center of the circle. What do we need to find? That is very instrumental. What we need is the gradient function, okay? The gradient function of the circle. So what we need is, what is key that we need is the gradient function of the circle, okay? What is the purpose of the gradient function of the circle? The purpose of the gradient function of the circle is that it gives us, okay, it gives us the gradient or the slope, okay, of the circle at any point, okay, at any point P that we define as the locus of all points. So we need the gradient function of the curve of the circle, not curve, of the circle, which will define what the gradient of the circle at any point of the circumference is. So what do? We need to get that equation of the circle. We say it is given as x squared plus y squared plus 2x minus 2y minus 8 equals to 0. For us to get the gradient function, we are going to treat the circle as implicit function, which are treated as an implicit function. If you have not yet learned differentiation, then don't worry. I'm going to use the simplest steps possible. So we shall treat it as an implicit function. That means we shall differentiate both sides of the equation with respect to x. So I'm going to say I'm differentiating the left hand side with respect to x. Okay? This is d of the function dx. That means we are differentiating the function with respect to x. The same thing applies here. I'm going to differentiate this side here, which is 0. I will differentiate it also with respect to x. That side of 0. So let us see how we can differentiate implicit functions. Now, remember we are differentiating with respect to x. So in your differentiation, If you differentiate x squared, what do you get? You get 2x. You get 2x. Okay? What function have you differentiated? X. So you're going to say dx over dx. But remember, we are not treating this as maybe division. No, we treat it as an operator. It's an operator. Okay? That's why we say d dx, but we don't say d over dx. But just for simplifying the explanation, I'm going to be saying at some points dx over dx, but it is not a function. It is not dx divided by dx. Okay, but in some sense it might means that. So it is an operator. So we have differentiated x squared, it gives us 2x, and it was a function in x, so say dx and then over dx, plus what if we differentiate y squared, it gives us 2y. What function have we differentiated? We have differentiated y, so we shall say here dy always over dx, which is dy dx. It is not division, but it is an operator. And then plus, if you differentiate 2x, what do you get? You get 2. And we were differentiating the function in x, so we shall say here dx dx. And then you come to negative 2y. If you differentiate negative 2y, what do you get? You get negative 2. It was a function in y, so we shall say dy dx. If you differentiate a constant, negative 8, you get 0. If you differentiate any constant, you get 0. Equals to, the same thing applies here. If you differentiate a constant, 0, it also gives us 0. So from here, you can see clearly that this and this are going to cancel, this and this will cancel. So that we say now here, therefore, we shall have 2x plus 2y dy dx, and then dx and dx will cancel, so we shall have there plus 2, and then minus 2 dy dx, minus 2 dy dx equals to 0. So what do we need to do? We need to collect the like terms, so that we add the terms containing dy dx and the terms containing dy dx. This means that I'm going to collect the like terms in this manner. I will have 2y dy dx. Our markers are running out. Let me try that. So written this 2 dy dx, 2y dy dx minus the term dy dx, which is 2 dy dx. Okay, and then equals, so I'm taking these other terms to that side of the equation, which is 2x, which when it crosses it becomes negative 2x. This 2 also becomes negative 2 after crossing the equal sign. Now I need to factorize this, so that dy dx is just a single term. So I'm going to just factorize. I will have 2y minus 2 dy dx. Okay, that is how we factorize that. I'll factorize out dy dx because it is common. Then I have 2y minus 2 equals to roughly negative 2x minus 2. Now let us make dy dx the subject. Why? Because dy dx is what we are calling the gradient function of the circle dy dx. So when we are looking for the gradient function of the circle, we are looking for dy dx. That means in this case here, therefore, dy dx here becomes equal to negative 2x minus 2 over 2y minus 1 minus 2, 2y minus 2. Okay, so this is the This is the gradient function of the circle. What does it mean? This is the function of the circle that gives us the gradient of the circle at any point on the circumference. So now, since this is the gradient function of the curve at any point on the circumference, now let us get the gradient of the circle at this point A, which was the point of tangency. So we're going to say at point 2, 2, it means that the gradient function, when we substitute in for 2 and 2, here now 2 and 2, then we shall be in position to get the gradient of the circle at that point. So let's substitute. We know that this is the value of x, this is y. So we substitute, we shall have negative 2x. What is x? X is 2 minus 2 out of 2y. 2, what is y? Y is also 2, and then minus that 2. That means here we shall have negative 6 out of 4 minus 2 out of 2. That means we shall have negative 3. Okay. So negative 3 is the gradient of the circle at point A. Okay. Negative 3 is the gradient of the circle at point A. Okay. Because we said the gradient function is just for any point on the circumference. So if we have point A, we substitute for the coordinates in the gradient function so that we get the gradient of the circle at that point A. So this negative 3 is the gradient of the circle at point 2, 2. Now, remember, this point on the circle is the same point where the tangent touches the circle. So at point A, the gradient of the circle is negative 3. At the same point, the gradient of the tangent is also negative 3. Okay, so at the point of tangency, the gradient of the circle is the same as the gradient of the tangent. Therefore, the gradient of the tangent is also negative 3. Okay, is also negative 3. Now from there, what do we do so that we get the equation of the tangent? Since that is the gradient, we know that gradient, which is m, new coordinate geometry, gradient m is given by chaining y out of chaining x. Out of chaining x. That means we shall have y2 minus y1 out of x2 minus x1. Okay? x2 minus x1. Then you come and use these coordinates. Okay? These coordinates. That is of point A that we have called, and they are given as 2, 2. The choice is yours. You can consider the given point 2, 2 as x2, y2 or x1, y1. There's no problem. You get the same answers. So let me just make it x1, y1 since they are the first points given. So substitute for them there. And you know that our gradient m is given by y2 minus y1 out of x2 minus x1. That means here we're going to have our gradient negative 3 equals to y2, which is not given, minus y1 is 2, which is here, out of x2 minus y minus x1, x2 minus x1, which is also 2. I'm not putting y2 here and x2 here. Why? Because those tools that we put there are just for comparing 2 points. Okay, are just for comparing 2 points, but you can leave them as y and x. Then from here, for it to be the equation of the tangent, which is a line, it must be in the form of y equals to mx plus c. So let's make y the subject. So we shall multiply both sides by x minus 2. That means I will have negative 3x plus 6, okay, equals to y minus 2. Therefore, when I make y the subject of the formula, I will have y equals to negative 3x plus 8. So this is the equation of the tangent to the circle at the point of tangency 2. I have tried my best to be very slow because these concepts are deep and we need to understand their foundation. So by the time you do example 5, this is just example 1, you will be familiar with how you find the gradient function. Then you find the gradient of the circle at that point, and then it is the same gradient of the tangent at that point, and then you come in with your formula for equation of the straight line in that sense. So this is the solution to part A.